So I will continue the talk, and I will discuss a bit more about how to do robust and multilingual analysis, what we mentioned and what is actually missing currently. I will strengthen a bit the point of why we would want to do that, and there's many applications to do robust text analysis. It's text analysis that is robust to noise, like Hannu mentioned. It could be noise from the capture of the text. Sorry, the image is a bit small, but it's a picture of the poster actually advertising this talk. But it's taken from the side. It's like many of the pictures you take with your smartphone. It's from the side. There's someone in between, in the front, and it's not so easy to read the text. You could do it by zooming, but it's especially hard for the computer. And then the text is probably not properly recognized. The first word is missing, is hidden by the person in front of it, and so on. And you still want to be able to do something out of that text. It's also the case of historical documents. I will discuss NewsEye, which is, Hannu mentioned, is a project on historical newspapers. But all historical documents, all digitized documents are actually concerned by this. So it's medieval manuscripts, historical newspapers, which are a bit easier because they are printed, but they come in hundreds of millions of pages. And also contemporary documents, which this one, sorry, is way too small. It's a bank document. Nowadays, we still have lots of, typically, especially in banks and insurance companies, lots of documents are not digitally born, or they are digitally born and printed and signed and sent in a scanned format. And then the text is lost because you have again an image and you have to extract the text and you will have errors. And this is actually a very, very active market in the document analysis. You want to be robust to noise or to errors in the digitization process, but you also want to be robust to language change. You want to have methods that work for the 6,000 languages or 7,000 languages, and not just the 100 that OpenAI is working with. So these newspapers here you have newspapers in German, French, and Finnish. Oh, this is impossible to read. Sorry. And then you also have to adapt to other language registers and dialects. So if you can process English, use proper English, fully written English, correct sentences, you still don't have the tools to analyze text messages. This is a text message where it says. What does it say? It's here. It's great to see you. GR8 T2CU. Digit and two letters, which is understandable for us. It's a code that people use in writing text messages, but of course, for the computer, it's not a proper sentence. It's very hard to analyze, and it's still English, but it's another way to write English, and it needs specific tools. And once you have done this, once you are robust to imperfect text, once you are robust to any language, you can use other types of scripts that we do not refer to as languages, but are sequential data that can be encoded, such as music partitions, music scores, sorry, in English, or the output of speech recognition. When you speak to your phone, it's recognizing you can use automatic speech recognition. It will translate what you're saying into text, and it will make mistakes because language is ambiguous. And we want to be able to analyze it and actually even fix the mistakes that the speech recognition tool is doing. And all that comes in the same kind of techniques. And we have worked a lot on that with Hannu in the context of the NewsEye project that he mentioned, which is a project called the Digital Investigator for Historical Newspapers. It ended last year, and we had many partners. The two main partners were my university and the University of Helsinki, with more than half of the budget, I think. So we were really the core of the project, and the idea was to we had three types of partners: national libraries, three of them, Austria, France, and Finland, computer science groups, and digital humanities group, or humanities groups, historians, researchers in literature, and so on. And the idea was to use the documents from the libraries, facilitate the access to them, allow to make large analysis on these collections, especially across languages, and make sure with the humanities researcher that they can really make new discoveries in history, and and that it's not just the computer scientists who are having, let's say, having fun in their own research and improving their scores by 3% and are slightly better at classifying documents and so on. The idea is really to be sure that every historian in our use cases can find new knowledge that they are not able to find otherwise. And the motivation of newspapers, I mentioned it earlier, it's that there's millions of documents. They are digitized, but digitized means taking pictures, basically. When you have a digitized document, you just have a picture of a page, and you have to recreate the content. And there's after millions of pages have been digitized, with a lot of funding since the 90s in all the libraries in Europe, there's actually a lot more to do before you can actually use these collections. And there's tools for that, but they are not working so well, and our goal was to improve them and bring quantitative analysis tools to historians who usually work with qualitative analysis. And of course, there's also strong interest from the public, because everyone, just like in Google, everyone types their name or types the name of their ancestors and finds, well, you can, it's used a lot by genealogists who can find dates, the announcement of weddings, an announcement of births or deaths in their families, but also sometimes some events where their relative might have been mentioned in local news for good or bad reasons. And there's a lot of challenges because of the quality of the source. You can see newspapers. It's interesting for us because they come in, like I said, hundreds of millions of pages. They are published every day. They are describing the past in the present tense, so with a perspective that we don't have anymore. And the problem is that they are not well preserved usually, because they are meant to be consumed daily or weekly, and they have to be cheap, and they are printed on cheap paper, and they are printed with cheap ink. And when they are saved for hundreds of years, even if they are saved in very good conditions, you still have marks like this in the place where the paper was folded a long time ago. You have stamps sometimes that will hide some characters. Sometimes you have even a piece of the document that is missing or that is ripped off, and part of it is cannot be recovered, and so on. So in this project, we had, just to give you a bit more background, we covered 1850 to 1950. We had access to 15 million pages from the three partner libraries. And our goal was to do things that work for every language, that can integrate more languages, more data sets, and where we can include more tools. And once more, we wanted to show that this is really useful for the humanities scholars, by having a wide set of research topics. So we had people in France, in Montpellier, who were working on the gender in literature. We're looking at typically one typical use case was the perception of women wearing trousers, which was considered shocking in the beginning of the 20th century, and how this was perceived and described in the press, and how it evolved, and basically how fashion evolved and how the perception of fashion evolved, and how it was judged. Something that sadly still happens nowadays. Then we had colleagues in the University of Helsinki who were working on the rise of the national sentiment in Finland, which is a very strong topic for this period, since Finland became, as everyone knows here, became independent in 1917. This was discussed in Swedish newspapers, in Finnish newspapers, and you can make a comparative analysis across languages to see how the perception, how the debate was different in different newspapers, based on their political orientation, but also based on their language, which might be correlated to their political orientation. We had colleagues in Austria, in the University of Innsbruck, who were working on migrations. Many types of migrations, typically a lot of it between Italy and Austria during the World War II, but also a lot more. And other works on media studies. So the idea is to have a panel of different research issues in different domains in the humanities. You see history, literature, and media studies in different languages, to really see that and try to conclude from that, if everyone has success in their research, that, okay, we have a method that works for French, for Finnish and Swedish in a cross-lingual way, for German in different fields, and therefore we succeeded, it should demonstrate that we have succeeded in doing something that works for all. And that was the main idea. To do that, we need to analyze text that is imperfect. I will just show you a quick example and then tell you how we did that. We have to face quite many challenges. Actually, the first one, even before we can extract the text, we have a problem, which is that we have, again, I said digitizing a document. It's just getting a picture. So you have a picture of a page like this, a lot of text, some pictures. You don't want to take all the text. You want to find the articles. All the articles here talk about something different. So the first thing you want to do is to separate the articles. And that is actually non-trivial, because here, as a human, you see it quite well most of the time. You see this column goes here. There doesn't seem to be an ending, so probably it goes on here. And there's a title. So probably this one, these two columns on the left-hand side are one article. Then there's a title, there's something, there's a picture. Is it ending here? Is it going on? Seems to go on. But then there's kind of a horizontal line, so probably stops here, something else. Then this is not clear, but you have a title that is overlooking the two columns, so probably this is again, the two columns are the same article, but even though there's a title here. So anyway, for us, we get an ID, but most of the time we actually have to read it to confirm the ID. And the computer has to work this out even before it can extract the text to avoid mixing everything up. Or actually, more and more, it's combining both tasks. That's another story. So first we have this problem, and then we have to extract the text. And the text, I picked an example in French, but you will see it's very understandable, even for those who don't speak French. You get the text format out of this content, and there's a lot of mistakes once more because the text is damaged, the ink has spread, the ink has disappeared. When you scan, often you even have the light that is used for scanning is showing you the characters that are on the back side of the page, and they come in your scan, and that creates even more noise. We call it noise. It's a bit an abuse of language, but it's visual noise. And then you get a lot of errors. But as a human, once more, with our human intelligence, we can read it very well because you know that the sentence is not starting with 01KE. And when you read the next word, as a French speaker, it's obvious that it's on. We do not speak, we do not publish the letter of the Kaiser. Also here, you know that one apostrophe is more likely L apostrophe. And when you read this, you can actually read this very well. The problem when you have millions of documents that are recognized like this, if you're interested in this person called Lord Tweedmouse, who is very an important character of this topic that is discussed here, you will type a query, Tweedmouse, and you will never find him because here is mentioned as tweed -MOU space TTJU. Because everything was mixed up, there was a line change, and the name was not recognized at all. Maybe there was some ink here, some problem, or maybe some stamp. And you will type this name, you will never find the document. And the problem for researchers, and I mean for anyone researching this kind of documents, is that you know that some documents are missed, but you have no idea how many. And if you are formulating a scientific hypothesis, you can work with the material you get from your queries, but you know that there's something else. There's a gray area with lots of documents, or maybe very few documents, and they might agree with your theory, or they might totally contradict it. And you have no idea if that's the case or not, and you have no idea if it's, and if you have no idea if what you're looking at is 10% of the collection or 99% of the collection of the relevant documents. So that is a major issue, and we want to focus on mentioning this Lord Tweedmouse because we know from studies, we worked a lot with Gallica. I don't know if people know this portal. It's a digital library of the French National Library. And we studied their logs. I mean, we studied, which means we studied what people have been querying in their digital libraries. And we found out that most of the queries, unsurprisingly, are people's names, locations, what we call named entities. So it's specific entities, like, well, the most typical one are really once more, person names, locations, city names, streets, region, and organizations, maybe a company name, a country, a region. Region is a bit ambiguous because it could be a location and a political, an administrative unit, and so on. So we want to find these entities. The idea is that the rest of the text we don't really mind because people will not query it, people will not look for it, and as humans, when we have the text, we can read it. But we want to find the entry point, which is these named entities, these person, locations, organizations. This is what we want to identify. So typically it is Kaiser and Lord Tweedmouse here. So we want to find them, we want to find that they are persons. And in fact, we want to do a bit more. We want to disambiguate these named entities. We want to know, typically when you have Washington, you want to know, is it the city, is it the state, is it the person, is it the president, is it someone whose first name is Washington? And here, if you have the Kaiser, well, you want to find out which Kaiser. If you want to make a query Kaiser, you will get lots of Kaisers. But you're probably looking for one specifically, and in this case, it's Guillaume II. And what we do, Guillaume II is also Wilhelm II or William II. And because we want to do something that is language dependent, we try to link every mention of a person name or a location or an organization to a unique identifier. And that identifier is typically what you can find in what is hidden behind Wikipedia. In Wikipedia, you have something called Wikidata, that is the data behind Wikipedia. And for every entity, you have an identifier, just a number, basically. And by linking everything, we can find every time that Guillaume II is mentioned in French, we have the same identifier than when Wilhelm II is mentioned in German, than when William II is mentioned in English. And we can collect all the documents together, and then we can do lots of analysis across languages, like Hanu mentioned on the sentiment. We can see how was the sentiment about Guillaume II or William II evolving in French, and how was it evolving comparatively in German newspapers, and in this and that German newspaper, and was it perceived differently in the Swedish and the Finnish newspapers, Swedish-speaking and Finnish-speaking newspapers of Finland, and so on. Okay, so now I stated my problem, but let's go back to ChatGPT. Can ChatGPT actually do this? Because maybe it's straightforward now with large language models. And the first thing we did is actually to introduce the talk is ask ChatGPT, can you recognize historical entities? And his answer is not very conclusive. It's just telling actually something, on the other hand, quite true. It's capable to identify entities, such as people, locations, and organizations in text, including historical documents. However, the ability to identify entities in historical documents will depend on the quality and quantity of the training data it was exposed to. And we all know, I'm just reading the beginning here, and we all know that ChatGPT was trained with web data, and web data is not historical data, most of it. So we will still check ourselves if it's working or not. So we used some benchmarks. One of them is Hype22. Doesn't matter, don't worry about this. It's just newspapers from, the name is not important, newspapers from 1800 to 1950. The named entities are marked in a lot of detail. So it's not just name, location. It's, for instance, when you have name, you have here you have Monsieur Daniel Meuron. So you mark up the title, Monsieur, you mark up the first name, you mark up the last name. There's a very, very fine, refined details. And for a location, you write separately the address, the street number, and so on. So it's very, very fine, very, very detailed. And then we have another data set, which is classical commentary. commentaries in English about Greek text. And this is quite interesting. I don't know if you can see this well, but we have text in English that is commenting about the classic book in Greek. So you have English, and suddenly you have a quotation in Greek. And let's see how well ChatGPT is doing with that. So we made queries, we made prompts, we sent prompts to ChatGPT. We asked it to what are the locations, persons, organizations, products, time periods present in the following historical text. We copy-paste the historical text that was extracted. And then we asked him to put it in a specific format that is easy for evaluation, that is the standard format for measuring the performance of any system. And then you see, if we start with the historical newspapers, well, this is our approach, which I will, this first and third are our approaches, which I will describe later, quickly. And the second and fourth are ChatGPT. And you can see that we are way above. The higher, of course, the higher the better. ChatGPT basically gets lost in the variety of categories. And when you combine it with English and Greek, and when you have this text, is what we call mixed code, so different alphabets in the same sentence, it's actually terrible. It has no idea what to do. Not only because it's Greek, but also it's ancient Greek. So that is something it has not been exposed to. Yeah, so that is that's very poor performance. If you give it something a bit easier, it's still below the performance of main systems. Not as far below as here, but still at least the 10 percentage point, or 10, the rate of success is 10% lower than what we can do without. And I would just tell you very briefly how we did something that works better for historical documents, that is robust to any language, that is robust to noise, and so on. The idea was simply to train with noisy documents, train with digitized documents in which some words are not properly recognized. And to do that, we need to have the document with the mistakes and the corrected documents to compare. The problem is that there's very few data sets like this. So then we had this idea. We reverse the problem. Instead of training with noisy documents and the correction, we take correct text and we put noise in it. So then we have something noisy and we have the correction that we actually had before. So we just take it the other way around. And for that, there's a lot of tools to take a text, very contemporary text. The US Navy did something in Yemen, in the country of Yemen, and you can, this is the original text, and then you can have bleed through, the one where you scan and you get the back ink showing up on the front side of the page from the scanning process. Phantom characters that appear from the degradation of documents with the ink spreading out, and so on, and a lot of typical noises of preservation that you can have there. And then, so you take your clean text, you make it dirty, so to say, and then you extract the text, and then you have the errors. And then so you just reverted the thing, and this way you can get an unlimited amount of noisy text and clean text corresponding to it. And then we trained with that, and then we used some advanced AI models that I will not detail. If anyone is interested, the main idea was to use many layers of transformers. I don't know if it makes sense to anyone. This is a way to look at more context. The idea behind it is most of the approaches in text analysis in AI, in deep learning, they look at some context around the word. When they analyze a word, they do not want to look at the word in isolation because there's a lot of ambiguity. They want to look at some amount of word before and some amount of word after, which tells you a lot more about what it means. And this, using many layers of transformers, is a way to look even further, because the idea is that when you have this noise, you cannot really trust the words that are next to the word you're looking at, because they might be false. But if you look further, the assumption is that, and it was verified, is that you get more relevant information than irrelevant information, so you kind of improve your understanding of the meaning. And then we went one step further, which is we took into account the period of publication, because language is evolving. the people who are mentioned is evolving, and the way to write is evolving, and so on. So we had changing approaches for different periods of time. And the outcome of this, especially in the context of NewsEye, is that we started from digitized documents, so pictures. We separated the articles. We found the articles. We extracted the text. We did what I just showed you. We found the named entities in every language. We found some opinion on the named entities. Like Hannu said, was the opinion about Tallinn positive, negative? In every article, you look at that. Every time Tallinn is mentioned, you look if it's positive context, negative context. And you link them together, and then you get a big set of annotated content where everything is language independent. So instead of having Tallinn, you have the number identifier of Tallinn. Opinion is not positive, negative, it's a number between 0 and 1. 1 is very positive, 0 is very negative. And 0.5 is neutral, and everything in between is changing. And then you have this linked. So you have the same identifier for Tallinn in French, Tallinn in English, Tallinn in German, Tallinn in Swedish. And then you can do very large analysis of how the perception is evolving across, like I said earlier, across languages, across newspapers, depending on the political orientation of the newspaper and so on. And then you can develop a lot of tools after that. And you can even access the collections directly in our tool. And we had very good performance for this name recognition and linking. And then we have this platform that is accessible to all. Where you will see that you can browse, you can access by person name, and you can search for a person and find all the documents, whatever the language, and you can do automatic analysis, but then you can go back to the documents to verify what the computer is suggesting with the reports, and so on. And there's many videos to explain, etc. And I think that actually concludes the talk for me and for us. Thank you very much.